Okay guys, so I created this video to go through the properties of squares notes with you. So you're gonna wanna be on this page. I'm gonna do number 6 and give you some time if you pause the video to try number 7, but also go through that one. So what's nice about the properties of squares is that they take on all the properties of shapes we've done before. So they're gonna take on the properties of parallelograms, right? That opposite sides are the same, opposite angles are the same, the diagonals bisect each other. That's going to be a really useful one. It also takes on all the properties of a rectangle, that we've got 90-degree angles and congruent diagonals. It's also going to take on the properties of rhombus. All the sides are the same. The diagonals meet at right angles. That's what the word perpendicular means. The diagonals meet at right angles. And the diagonals are going to cut opposite angles in half. That's what that word bisect means. It means cut in half. Okay, it's going to cut angles in half as well as lines in half. So all of this stuff is going to be really helpful and useful for us. So I'm going to go ahead and do number 6. So what I know is that the shape I'm starting with is a square. And one of those sides is 11. So the first thing I'm asked about is BC, which is another side to the square. Squares take on the properties of a rhombus. 4 congruent sides. That means all of these sides are the same. All of these sides are 11. BC is 11. It also asked me for the length of AC. So I'm going to take out my highlighter to show you what's going on here. I want the length of AC. Now, all I have are side lengths to use here. But just like in a rectangle, all my corners are right angles. They're all 90-degree angles. So what ends up happening is I actually have a right triangle where I have one leg and the other, but I'm missing my hypotenuse. I'm missing C. So let's set up the Pythagorean theorem here. We know the Pythagorean theorem looks like this. I have my A, which is 11. I also have B, which is the same thing. Remember, it's a square. And my C value is what I'm trying to find. So 11 squared is 11 times 11. I still don't have C. So we'll add those together. But I only want C. I don't want C squared. So what I have to do to cancel out the power of 2 here is I have to take a square root. Now the square root of 242 is going to be a decimal, and that's okay. My C value is 15.6, roughly, if I use a calculator. So that means my diagonal AC is 15.6. Then it asks me for BD. BD is the other diagonal. Now, squares are rectangles, so I know the diagonals are supposed to be the same. This other diagonal is also going to be 15.6. Diagonals are congruent. Then it asks me for EC. But squares are still in the parallelogram family. So these diagonals also cut each other in half. I take 15.6 and cut it in half. I take 15.6 and I divide it by 2. So EC would be 7.8. Then we're going to move on to these angle questions. And if you notice, they don't give me any information about the angles. All of this is going to come from the properties of a square. Now, the first one they ask me about is DAB. They're asking me about the corner here, the whole corner, which for a square is a right angle. It's 90 degrees. Then they ask me about angle B. A, E, B, which is where these diagonals meet. A, E, B. It's where those diagonals meet. Which, for a square, just like a rhombus, diagonals are perpendicular. Diagonals meet at right angles. So again, we have another 90-degree angle. Then it asks me for C, B, D. C, B, D. That's a piece of an entire corner, right? The whole thing would be 90 degrees, but I only want a part to it. Here's where another rhombus property comes in. In a rhombus, diagonals bisect opposite angles. They cut angles in half. Not only do they cut each other in half, they cut angles in half too. What's half of 90? 45. B, A, C. B, A, C. I'm tracing these letters with my pen to figure out where the angles are. BAC is another piece of a corner. Every corner of a square, just like every corner of a rhombus, gets cut in half. The entire corner is 90. Half of 90 is 45. So at this point, I'd like you to stop the video and try number 7. If you do get stuck, you can resume the video. I do go through the entire number 7. If you do complete it on your own, you can skip to the end of the video for the answers to that. Okay, so at this point, you probably resume the video to figure out if you did what you did was right. So this problem follows very similar to the one that I just did. So what I know again is that this shape is a square, but this time they give me the length of TR. They tell me that the part of that diagonal is 17. That should be enough to figure out everything over here they ask me about. First thing they want is the full diagonal. Well, if I have a piece of it, I know the rest is also 17. So the total diagonal length would be 34. They also ask me for the other diagonal length. Again, diagonals in a square are congruent. They're the same. So once I find one, I have the other. If this whole diagonal is also 34, that means both of these pieces from Q to T and from T to S, right? Both of these pieces, again, are 17. But then they ask me for a side of the square, which I didn't start out with this time. However, diagonals of a square meet at right angles. Does everyone see that I've created another right triangle here where both of my legs are 17 and I'm missing my C value? I'm missing what's across from the right angle. I've got to set up Pythagorean Theorem. Ooh. This time, my A and my B are still both 17. They're the same value. And I'm missing my side C. 17 squared plus 17 squared is 578, which is equal to my hypotenuse squared. But to get my final answer, I need to take a square root. The square root of 578 is about 24. So that's the side of my square. That's PQ. If I asked you some more questions like, what is PS? Remember, sides of a square are all congruent. All of these sides would be 24. So I only have to do that solving once. The rest of these questions come down to properties for a square. And then it asks me about the angles. Your two options here are 90 or 45. In a square, and only in a square, you cannot have anything else. Angle PRS. I'm going to again take my pen to trace these angles out. PRS. PRS. I'm asking for this part of a corner. The whole thing was 90. Angles are bisected in a square. So this answer is 45 degrees. It also asked me for STR. Diagonals are perpendicular in a square. STR is a right angle. It is 90 degrees. PSR. It's asking me for the corner of this square. Corners of a square are right angles, 90 degrees. QPR. QPR. QPR is asking me for a piece of a corner, which is again a 45-degree angle. Now, at this point, you can stop the video. If you would like to challenge yourself to maybe see if you can get a bonus test question correct, I ask that you try 10 and 11. Otherwise, you can move on to the following two pages, as well as this page as a quiz review. There's another video where I go through the answers to this, so click that link if you'd like to see that tutorial.